Hello, everyone. Thank you so much for coming out early to Eat Denver. I know the main event doesn't start until tomorrow, so it's awesome that y'all are here. And I'm really excited to talk to you about connected contracts on Moonbeam. So if you've listened to some of our workshops before, you might have seen that we talk a lot about XCM. We also talk a lot about connected contracts. And so I wanted today to talk about something a little bit different than XCM, and instead to talk about general message passing. And when we talk about general message passing, this definitely encompasses XCM. But typically when we say XCM, we're talking about inside of Polkadot. And then when we say GMP, we're typically talking about Moonbeam's connections outside of Polkadot. So that includes the chains like Ethereum, that includes chains like Polygon, Optimism, many others. And so today I want to run you through an example of what it would be like to interact with another chain. And basically, we'll look at some of the mechanics of how this cross-chain contract call works. So there's typically two types of transactions that you would want to make. One is just to call a contract on a remote chain. It could be as simple as sending a message. We have several tutorials that show you how to send hello world messages to other chains. But more likely, you're probably going to be calling a contract. And that could include things like buying an NFT. It could be making a swap. It could be depositing some collateral. It could be anything. Anything that you can do on a blockchain, you can make that into a cross-chain call. And we'll go into exactly what that looks like in just a sec. So another option is you could also call a contract, but also send along tokens with it. And this would be like your bridging operation. And when we talk about bridging, if you're just going to a bridge like Wormhole, for instance, and you're bridging tokens, that's a subset of general message passing. So you're bridging value, and that is just the application that you're making with the GMP provider, with Wormhole in this case. So in this example, I have a tangible hypothetical example that I want to give you. And we'll be using Axelar here as the GMP provider. Now, a lot of these GMP providers, they work pretty similarly. There are some differences, but I felt that this is a great example to use to demonstrate. And if you understand one way, then you're probably quickly going to understand how the other ones work as well. So let's say that we'd like to mint an NFT on Polygon. And the NFT mint is free and open. But I don't have any Matic tokens. I haven't set up a wallet yet on Matic. But I do have Glimmer tokens on Moonbeam. And so what I can do is I can send a message from Moonbeam through Axelar to actually buy that NFT for me. And I can have that NFT sent to the same wallet address that I own on Moonbeam, just on the Polygon network. And I don't need to go out, and I don't need to go out and buy Matic funds. I don't need to change the network in my MetaMask. I don't need to go and add some new RPC URL and switch networks and have a bunch of pop-ups. Instead, I can confirm one transaction on Moonbeam, have it go through Axelar, and then take the action that I want to take. Now, we're showing Polygon here as an example, but there's a huge number of other chains. So if you want to buy an NFT on a layer 2, if you want to buy an NFT on Ethereum, if you want to buy it on a whole host of other chains, that's also possible as well. We're just using this for the example. So there are 3 steps. There's the destination chain, there's the Axelar network, there's the origin chain, so that's Moonbeam, there's Axelar, and then there's the destination chain, which is Polygon. So let's take a closer look at what we're doing in each step. So on Moonbeam, with the source chain, if I have a dApp that I'm creating and I want to use it to purchase the NFT on Polygon, the first thing that I'm going to do is I'm going to call the Axelar gateway contract. And the Axelar gateway contract has a couple different methods, but the 2 ones that we're going to be talking about are the call contract or the call contract with token. And that corresponds to exactly what I mentioned in the last slide, which is the 2 main use cases that we're going to use GMP providers to do. So when you call the Axelar gateway, it's going to ask for 3 simple parameters in call contract. That would be the destination chain. So that would be Polygon in this case. That would be the destination address. If we are minting an NFT, that will be the NFT contract itself. And then it's also going to take a payload. So this is the call data. What is the function that you want to call? What are the parameters that it requires? And it's going to look and feel exactly like just a regular contract call. So there's nothing special here, just the function that you want to call and the parameters. So in this case, if you are doing this free mint, you're probably going to need to provide an address that you'd like the minted NFT to go to. You also, depending on the NFT contract, you might have to specify, I want 1, I want 2. So we'll specify an amount of, let's say, 1, right? So that will be wrapped up in the payload. Now, one important thing to mention is that the GMP providers do use different chain IDs than the typical EVM chain IDs. So Ethereum's EVM chain ID is 1, Moonbeam's is 1284, but a lot of the GMP providers will have specific identifiers of their own. And you can look those up on the docs site for each of the GMP providers. OK, so just in a bit larger font, all we're providing, 3 things: destination chain, contract address, and the call data. That's it. If we are sending a token along with the cross-chain function call, we are going to have to include a token symbol and also the amount that we're sending. So this is if we use call contract with token. We're going to have 2 extra parameters that we need to provide. OK, and the last step here of what happens on the origin chain, which is Moonbeam in this case, the last thing is that we're going to have an event emitted that corresponds to the call contract or the call contract with token. And the Axelar network is going to be listening for these events. And if it picks up an event, then it's going to move on to process it and validate it and make sure that it's valid. So let's talk a little bit about how that works. So the Axelar network, as it is now, has about 75 validators. This is a decentralized set and a distributed set. And it's architected in a way that only one validator needs to be honest or just up and running. So if 74 of the nodes are down or they're malicious, we just need one that's working, and we need one that's going to pass along the call. So the Axelar network will process the call. It's going to perform a couple checks. So what is it going to check, right? It's going to check to make sure that you provided enough gas to execute the transaction on the destination chain. So let's step through that a little bit more closely. So the origin chain is Moonbeam. You're going to pay gas just like a normal transaction on Moonbeam. So you've got your normal transaction fee. But then you're also going to send along some value. And this value is just to pay for gas on the destination chain. So Axelar has an SDK, so you can calculate how much gas you need in order to send along with it in order for the call to be executed. So Axelar will tell you what you need to send along, and it will take care of the payment on the destination chain. So you're not getting Matic tokens, you're not doing a swap, you don't have to do any of that. Axelar takes care of that. And so as part of this check, it's going to make sure that you have enough. And if you forgot to, it'll say, it'll give you an error, and you'll be able to add the funds that you need, and then the call can continue. If it's approved, if everything looks good, it'll go through the process, and then it will call the gateway contract on the destination chain. And, whoops. Once it goes to the destination chain, this is step 3. This is now happening on Polygon. When it gets to the destination chain, it's going to call the approved contract call, also of the gateway contract. And this gateway contract, again, is deployed to every single network that's within the Axelar network. So we have Polygon in this example, but it would be the same thing if it's deployed onto another network as well. So approved contract call, that goes through. Lastly, we get to payload executed. And this is a normal contract call. The NFT contract, where we're doing the minting, it does not care if it's cross-chain or if it existed on Polygon originally. It can't tell. There is no difference. And this is very important because it means that you don't need to re-architect smart contracts. And it means that your cross-chain call is going to behave just like a regular function call. And so what that means is that if, for example, the NFT contract had some sort of whitelist, and if you, let's say, were not on that or something like that, if you didn't meet some certain requirements, then it would fail just like a regular transaction. So this sort of cross-chain interaction is just like a normal contract call. So with Moonbeam, you can reach any user and any asset on any chain. And we'll dive into a bit more of how this works. Moonbeam is the best place to deploy your application because you don't need to worry about, hey, if another like L2 pops up and I need to have access to the users on that chain, or if something pops up overnight, you don't need to worry about saying like, how do I access these users? How do I access the liquidity on this chain? The reason for that is because the GMP providers are adding new networks all the time. So if Axelar adds a new network, Moonbeam doesn't have to do anything. Moonbeam is connected to Axelar, and so we're going to be connected to whichever new network that Axelar adds, which is really, really cool. So Moonbeam has a ton of different GMP provider integrations, and this is a big deal. Personally, for personal developer preference, some people might be more comfortable with one versus the other. And secondly, for redundancy. Some GMP providers do have scheduled downtime during short windows. And so you might need to have another way to get your message across during that time period. And it's always good to have a backup. So Moonbeam is integrated with Axelar, Wormhole, Layer 0, Hyperlane, and all of these are great, great options for building a cross-chain connected contract. So I want to talk a little bit more. We'll zoom out a little bit from the specifics of the cross-chain message, and we'll look a little bit more at an overview of cross-chain connected contracts and multi-chain components. So the first thing is that we've had this belief for a while, and it's that the future is multi-chain and cross-chain. And part of the reason for that is because it's so easy to launch a new chain. Tansy will be on stage in 2 talks from now, and you'll learn about how you can launch an app chain very, very quickly. And there are layer 2s spinning up all the time. And so we believe that this proliferation of chains is going to continue. And so do we want to be in a spot where users are kind of bouncing from chain to chain and having kind of a difficult experience moving between them? Or do we want to have one that's a lot more fluid that doesn't require users to constantly change their network, but gives them the benefits of accessing assets, users, buying NFTs, and doing all of this in a much more enjoyable manner? In kind of the years past, the common kind of solution to building like a multi-chain approach was to pick one chain, 1 or 2 chains, and then say like to your users, hey, we're here, come find us here. You can bridge to them. You can go and buy native tokens, and then you can interact there. But this is definitely segmenting your users, right? You're asking them to bridge. You're asking them they may need to set up a new wallet. And so that's a little bit tricky. And in another case, this kind of evolved right onto, okay, rather than picking 1 chain or 2 chains, we're going to say, let's just deploy everywhere, right? And let's deploy the same exact thing to all these different places. And for certain DeFi apps, right, you're going to fragment your liquidity. You're going to fragment your users. You might have features that are specific to one particular chain. And as you know, if you're working with DeFi, you want to have the deepest liquidity pools. You want to have the best trades, with the lowest slippage and stuff like that. And so that is enabled when you have more of a connected contracts approach. And so one of the things that you can do is you can design a kind of a hub and spoke architecture where Moonbeam is the kind of the brains of your application. And then you can have satellite smart contract logic on connected chains. So as an example, gas on Moonbeam is cheap. And so you can have more complex computation on Moonbeam, making decisions within your smart contracts. And perhaps you have things like depositing collateral, a simpler operation. Perhaps you have that on Ethereum or your other connected chains. So to reiterate, general message passing is what enables this connected contracts approach. If we didn't have the GMP providers that are connecting all these different chains together, we would have a very, very difficult time. So it means that applications on these blockchains can have more of a unified approach. They can be aware of each other, so they can benefit from liquidity on multiple chains. And so rather than having distinct deployments that don't know about each other, that don't benefit from each other, you can have a more holistic approach where the liquidity could be shared, or you can tap into assets on other chains. And one example that I want to highlight, Prime Protocol is a cross-chain prime brokerage. And a prime brokerage in traditional finance is kind of like a bank that handles the assets of VIP clients. And so if you're a prime brokerage client, you might have stocks, bonds, maybe you have physical assets, houses, boats, everything like that, with the bank, stored with them. And so you can go to them and you could say, hey, I want to get started on a new business venture. I'd like a loan. I'd like a $10,000 loan. And they'd say, well, we've got all your stocks, your bonds, your boats, your houses. Like, we have no problem giving you a loan. But in the blockchain world, it's more of a separated thing where you need to have the assets that you want to borrow against on the same chain. So if you want to borrow on Ethereum, typically you need to have your collateral on Ethereum. And if you want to borrow on Moonbeam, typically you would have to have your collateral also on Moonbeam. So let's say you have Ethereum that you wanted to use as collateral, and you want to take out a loan on Moonbeam. Typically, you'd have to bridge that ETH over to Moonbeam and then deposit it into a smart contract, and that will give you a loan on Moonbeam. But with Prime Protocol, you can keep your ETH on Ethereum. You don't need to bridge it over to Moonbeam. You can keep it in its native form on Ethereum, and you can deposit it into a satellite smart contract. And Prime Protocol will recognize that. It will secure the collateral, so the protocol has ownership of that collateral, and then it will give you a loan on Moonbeam. And so the brains of Prime Protocol that are managing the liquidation decisions, that are managing how much collateral you need to have, all of that's happening on Moonbeam. And then in the case where you need to post more collateral, or the case where you need to be liquidated, the decision would be propagated from Moonbeam out to the satellite smart contract, which could be Ethereum, Avalanche, Polygon, Arbitrum, and there are several others that Prime is working with, and that is quite cool. And just another thing to add, if you prefer, to play around with this, maybe not on mainnet, then you should be able to play around with it on testnet. Many of these applications are deployed also to testnets as well. So for the last, right before I wrap up, I do want to highlight one more thing, which highlights kind of the intersection of GMP and XCM. So, and that's Moonbeam routed liquidity. And Moonbeam routed liquidity is a solution to get assets from outside of Polkadot very easily into Polkadot parachains. And so the idea here is that you may want to bring assets from outside of Polkadot, maybe Ethereum, maybe ones on Avalanche or Polygon. Again, many others. We're just showing 3 here just for illustration purposes. But you can bring those in through Wormhole, and all in one transaction, you're going to be doing what we talked about before, which was that a method similar to call contract with token. And once it arrives to Moonbeam, it's going to hit the GMP precompile, and it's going to be routed to the destination parachain. This happens all in one step. So it isn't going from outside of Polkadot. It isn't like staying in Moonbeam for like 20 blocks or whatever. It's the exact same. It lands on Moonbeam, and then it instantly gets routed to the destination parachain. And when I say one click, it's the typical bridging experience where you might have to do an approval one, but then you'll have your transaction confirmation, and you'll specify the destination just like you would on any other bridge. So you may not have to worry about like what's the destination parachain. You may not even know that it's going through Moonbeam and then going to Polkadot. So going to a Polkadot parachain. So you'll just have the destination as Hydrodex or whatever the parachain is that it's going to. You'll select that on the interface. Carrier is one interface, and Carrier uses Wormhole, and then it comes in through Wormhole. It goes to Moonbeam, and then it gets routed to the destination parachain. OK, and that's it. Thank you so much for your attention. And if you'd like to check out the slides, you can access them at bit.ly/moonbeamdenver.